So, what we're starting today is chapter 3. Now, for the most part, y'all should have watched the video for 3.1.1, as I know one of y'all have already finished the assignment for this here, but that's fine because it worked out that the other classes ended up not getting there, so I had to backtrack a little bit. But we are going to go over this today and tomorrow. So we're going to be doing this today and tomorrow, working on factoring. And we're going to do one example of distributing, which is kind of the opposite of factoring. We're going in the other direction. So if we distribute these here, we multiply through. Well, we'd first do 4x times negative 3. Well, not 4x times negative, sorry. 4x times x, which is 4x squared. Then we would do 4x times negative 3 next, which would be negative 12x. Then we would do negative 5 times x, which is negative 5x. And lastly, negative 5 times negative 3. The negative and negative make a plus. And 5 times 3 is 15. Now the last thing we would need to do is combine like terms, which would give us 4x squared minus 17x plus 15. And that's it. Now, what we're going to be doing is taking the quadratic and factor it back. So we're going to do the opposite of what we just did. So when we factor, that's the direction we're going. And there are several steps that do help us be able to factor. Now, I'm not going to worry about these here. Yes.
That's the perfect food basket. She loved it. He ran into her room. He was outside.
So, previously you have factored polynomials of the form ax squared plus bx plus c, where a is equal to 1. And when they say previously, they mean algebra 1. Because we haven't done a whole lot of factoring in here yet, but we will be doing some, especially with this here. Especially factoring when the value of a is different than 1. And in any way, or any of the different methods for factoring, the first thing we're going to look for is a greatest common factor. Now, there are different methods to factoring, different ways to factor, but all of them do agree that the first thing to look for, or the first step in factoring, is to see if it has a greatest common factor. If it does, we're going to factor it out. So when we look at this one here, 5x squared plus 15x plus 10. Is there a greatest common factor between 5x squared, 15x, and 10? 5. 5 will go into all three terms. So we can factor it out. And when we factor it out, we're more or less dividing each term by whatever the greatest common factor is. Right, so 5x squared divided by 5 would leave us with x squared plus 15 divided by 5 is 3. We still have the x. And 10 divided by 5 is 2. Now there are, again, as I said, different ways to factor, different methods to get to this here. And the one that I find the most helpful is this here. These steps that we're going to list out. The second one is to write 2 sets of parentheses with 3 spaces. So for us here, we will still have the greatest common factor of 5. But we're going to have 2 sets of parentheses with 3 spaces. Now the 3 spaces helps us to space it out, space the parentheses out so that we have enough room for everything to fit. And what's going to go in these spaces is kind of what we had here, and here we're going to have two terms and a sign in the middle for each one. And possibly, but the next thing we'll look at, because we can go all the way there, but the steps will get us there. The third step that we have is to find the signs. We need to figure out what signs go in the middle. We need to figure out what signs go in the middle. Now for us, if the third term is positive, then the signs are the same and match the sign of the middle term. Of the middle term. So if the third term is positive, the signs are the same and match the sign of the middle term. We can go and put the other part. If the third term is negative, then the signs are opposite. So the other part of this, if the third term is negative, then the signs are opposite. Third term is negative, then the signs are opposite. So if we look back at this one here, if we look at the third term, is the third term positive or negative? Positive. If the third term is positive, which it is, the signs are the same and they match the sign of the middle term, which is also positive. So the signs are both positive. Questions on this here so far? Step number 4. Find the factors of the first and third term and plug them in. And the last step is to check. Yes. So if we look back at this here, factors of the first term, well, we're finding the factors of what? So what's the first term? X squared. So what multiplies, or what two things multiply together to give us x squared? And x. It actually works out those are the only factors of x squared. We only have these two here. And if there's only one set of factors, we're just going to plug them in and move on. Factors of 2 are, well, 1 and 2, because those are the only factors of 2, so we plug it in. And the last thing we need to do is to check. Last thing we need to do is check it. Make sure we got the correct factors. Now, most would say that we need to distribute all the way through. And that's not wrong. I think it's a little too much going on. There's too much to it. And not that there's too, I mean, you'll see here in a minute. Now, what does x times x give us? X squared. Well, where did we get the x and x from? X and x are factors of x squared. So when I multiply them back together, I should get back to x thing. Same thing. Because I got them from x squared, they should multiply back together to be x squared. So we'll have, I'm going to leave a little bit of, well, our next one would be x times 2, which is positive 2x plus 2x, yes? Then we would do 1 times x, which is plus 1x. And then lastly, 1 times 2 is plus 2. Well, where did I get the 1 and 2 from? They're the factors of, so should they multiply together to be 2? Yeah. So when I said some of this is not completely necessary, one of them is our x times x and 1 times 2. Those are the factors of x squared and 2. So they should actually multiply back together to be x squared and 2. There's not a whole lot of reason to check those because they're always going to work out to be the same. The one that we do need to check is our middle term, which in this case is our, well, apparently it's not going to pick that color, the x times 2 and our 1 times x, which in this case gave us 2x and x, and 2x plus x is 3x. That is an awful color to see on this board. But it is positive 3x. Is that the middle term we wanted? Yeah, because we wanted it to be positive 3x. It is indeed positive 3x. So 5 times x plus 1 times x plus 2 is the factored form of this quadratic. Questions on this here? We're ready for the next one. Factor 4x squared plus 32x plus 60. Well, our first step is what? Greatest common factor, GCF. Is there a number or term that will go into all 3 terms? 2, yes, but there is a bigger one. 4. There is not a variable because 60 does not have a variable attached to it. So we're looking at a number, and 4 is the biggest number that goes into 4, 32 and 60. And if we divide 4 out of 4x squared, we're just left with x squared. If we divide 4 out of 32x, we're left with 8x. And 60 divided by 4 is 15. So that takes care of step number 1. Step number 2, we need to write 2 sets of parentheses with 3 spaces. Any questions on steps 1 or 2? Step number 3, find the sign. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. Well, what's the sign of our third term? So the signs are the same and they match the sign of the middle term, which is So our signs are both positive. So plus and plus. So that takes care of steps 1, 2, and 3. Step number 4, find the factors of the first and third term. Our first term is what? X squared. X and X. Really with X squared, T squared, U squared, anytime we have that variable squared in that first spot, it's going to be T and T, U and U, Y and Y, whatever the variable is, that's the only way it works out. What's the number in front of X squared? 1. So we're just left with X and X. Now the other one we're finding the factors of is, does 15 have one set of factors? So what are the factors of 15? 1 and 15. Does it have one set of factors? No, it has 2. Unlike the last one and unlike X squared, we have to actually pick which set of factors we want to use. 3 and 5. Now, we do 3 and 5 and we can check this here. Now, let's use bright yellow. Because if we went on and multiplied this all the way out, X times X is what? Just like we expect it to be, yes? Because it's the factors of X squared, so we should expect to get back there. How about our 3 times 5? Because they're the factors of 15. The one that we do need to check is our X times 5, which is 5X. Now 3 times X would be plus 3X. Because I just wrote 5X because it is positive 5X. We don't necessarily have a number in front of it, so we don't need the plus symbol. But we will combine these like terms, 5X and 3X is that the middle term we wanted. So these here would be the correct factors. Now, I'm going to do this just for y'all so that y'all can see this. Because if we chose 1 and 15 here, well, looking back at this, because the numbers did change, well, the first one's still X times X, yes? And that's still X squared. Our other one, 1 times 15, that's still 15. Those don't change. Because the only way that they wouldn't give us those, the correct values, is if we got the wrong factors. So those don't change, and the ones that did are here. X times 15 is now 15X. 1 times X is now plus X, giving us, is that the middle term we wanted? No. So by changing the terms and the factors we put in this first spots and others in these 4 spots here, it didn't change what the first term was or the third term, but it did change the middle term. And we can see that 1 and 15 is not the correct setup for this here. It should be this here. So the correct answer is 4 times X plus 3 times X plus 5. Questions on this here? Are you ready for the next one? 4x squared plus 13x plus 3. What's our greatest common factor? Yeah, there's no greatest common factor other than 1. But the 1 doesn't really help us. So if it, what number will go into 4, 12, and 3? Right, having it be 12 wouldn't help because 4 and 3 don't have a greatest common factor. So we'd have to change more than just one number for it to have one. So, no greatest common factor, not all of them will have one. So that moves us on to step 2, our 2 sets of parentheses with 3 spaces. Step 3 is to find the sign. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. Well, what's the sign of the third term? They're the same and they match the middle term, which is? So we have plus and plus. Brings us to step 4, find the factors of the first and third term. Well, the first term is what? 4x squared, yes? Well, our x squared factors are going to be what? X and x. That's the only way it works out. So we can go on and just put those in.
Wait, if the first one is negative, it'd be different, but would it match the middle term again?
Nope.
Stay at plus?
If the third term is negative, then the signs are
Opposite.
opposite.
How do you know?
We will get there. But they're just opposite. Because we will cover problems like that, but they're just opposite. If the third term is negative, one's going to be positive, one's going to be negative.
Okay.
Now, what are the factors of 4? Well, we have 1 and 4, and 2 and 2. Now, at this point here, we just need to pick. Doesn't matter which one we pick, because we will check it eventually to make sure it works. So what do we want to try first, 1 and 4 or 2 and 2? 2 and 2. So we'll put those in the first spots. Factors of 3 are? Anything else? So we can just plug those in. So we have all of our terms plugged in, which brings us to step number 5, which is to check it. Now 2x times 2x is still 4x squared. 1 times 3 is still 3. So we really don't need to check those. Now 2x times 3 is 6x. 1 times 2x is plus 2x. And 6x plus 2x is. So is 8x the middle term we wanted? What we can do next is we could switch the 1 and 3's location. We could flip it. Would that do anything? No, because the 2x and 2x, yes? Well, the next thing we could try doing is switching the 2x and 2x, yes? It's the same thing. So we need to switch out. So let's try 1 and 4. Where do we want to put the 4? First set of proof. Okay. It will eventually, but where we put it first isn't going to make a big difference because we need to check it. So if putting it in the first spot is the correct location, when we check it, it'll tell us that it is. If it's not, it just means we have to switch it. 4x times 3 is 12x. 1 times x is plus x. And 12x plus x is that what we wanted? And that's it there. Now, a lot of factoring, the more of these that you do, the better you'll get at them, and the more that you'll see which ones will probably work best or more likely be the correct setup, and go to those there. And then we'll always want to check just to make sure. Now, let's look at the next one. 3x squared minus 7x plus 2. What's the greatest common factor? One, 3, 7, and 2 are actually all prime numbers. So we move on to step number 2, our 2 sets of parentheses with 3 spaces. Got that finished. Step number 3, find the sign. If the third term is positive, then the signs are the same and they match the sign of the middle term. So here, the third term is what? Third term sign. Positive. Since it is positive, the signs are the same and they match the sign of the middle term, which is? So the signs are, if the third term is positive, then the signs are the, and match the sign of the middle term. So the third term is, what is the sign of the middle term? So, and match. If we match, we are the, so what's the middle term? Minus. So the signs are going to be minus and minus. Because for the third term, when we multiply them together, the only way we can multiply two things and get a positive is if one, they're both positive or they're both negative. So if the third term is positive, the signs are the same. They're going to be the same in both sets of parentheses, and they're going to match the sign of the middle term. If the third term is negative, then the signs are opposite. So here, the third term is positive. So the signs are the same. They're either both going to be positive or both going to be negative, and they match whatever the middle term is. Since the middle term here is negative, they're both negative. Now we need to find the factors of the first and third terms. First term is what? 3x squared. So we know for sure we'll have x and x, because x times x would give us our x squared. What are the factors of 3? 1 and 3. So we need to determine which parentheses would have the 3. Doesn't really matter, we just need to pick one. First one or third, second one? First one. So we'll have 3x and x. Factors of the third term, factors of 2. What are the factors of 2? 1 and 2. Which parentheses would have the 1 and which one's going to have the 2? Do we want to put the 1 in the first one or the second one? Not at this point. We will check it and make sure it is correct. Here. So we just need to pick it because, again, the check step will make sure we have it set up correctly. If not, we would flip the 1 and 2 and then go from there. Now, the main ones we need to check is the 3x times negative 2. 3x times negative 2 is negative 6x. Happy birthday. Our negative 1 times x is negative x. And negative 6x minus x is what? Negative 7x. Is that the middle term we wanted? Yes. Questions on this here? Questions on anything we've done so far? Let's look at this one here. This will be the last one we look at today. We will finish this note sheet tomorrow. 2x squared plus 7x plus 6. Is there a greatest common factor between these three terms? No. So we'll have two sets of parentheses with 3 spaces. So our third term is positive. So our signs are the same and they match the sign of the middle term, which would be positive, so plus and plus.
You were so close to getting it. He was like opposite.
No. 2x squared, well, we know the factors of x squared are x and x. What are the factors of 2? 1 and 2. Are there any other factors? No. So we just need to pick a spot for the 2 to go. No. So So we can put the 2 in the first one. What are the factors of 6? 1 and 6, 2 and 3. So we do have more than one set of factors for 6. 1 and 6. Now if we check this here, 2x times 6 is 12x. 1 times x is x, which gives us 13x. Why would we not want to just switch the 1 and 6 and try that?
I did 1x plus 1, 2x.
Because if we,
Yeah, that's what I just do.
2x times 1 is 2x, yes? 6 times x is plus, which gives us 8x. Is that the middle term we want?
No.
There's one other thing I do want to point out with this. With how this is set up, if we look at the first parentheses, 2x plus 6, is there a greatest common factor there? There's a greatest common factor of? If there's a greatest common factor in either of the parentheses, it means there had to be one to begin with.
Oh, we did it wrong.
Well, is there a greatest common factor between 2, 7, and 6? Is there a number that will go into 2, 7, and 6? So what that's telling us is since there's not a number that will factor in all three here, there cannot be one in either location. So 2x and 6, can they go together?
No.
Because 2 and 6 have a greatest common factor of what?
2.
Right. So here, I can't have this greatest common factor of 2. What other number can't go in 6's place with the factors of 2? Well, 2, because we can't put 2x and 2, because here, if I set it up this way, is there a greatest common factor between 2x and 2?
Yeah.
Is there a number that will go into both 2x and 2?
Yeah.
Yeah. If this was actually this worked, it means that there had to be a greatest common factor here. Is there a greatest common factor to begin with? Which means in any of our parentheses, there cannot be one either.
So that's wrong too. So we can't do greatest common factor. So switch the 2.
Right, we would need to switch it. If we checked it, 2x times 3 is 6x. 2 times x is plus 2x, which gives us 8x. That's still not the correct one. If we switch the 2 and 3, 2x times 2 is 3 times x is plus 3x, which gives us.
We did it.
Mm-hmm. We will be going over more of these tomorrow. Mm-hmm. Right, it's because that there is something, one of the things that when you start doing more of these, you'll start noticing patterns. And when you notice the patterns, it makes them easier. But it does not make them, if you don't see it, it doesn't prevent you from finding